I'm just going to finish up with the last feature from the class blueprint code, which is you were able to attach something to your gun. You're able to pick something up, grab it. Actually, I don't think that this code is the right code. I guess it is. It just doesn't shoot anymore. Yeah, nothing works. But I think I broke this project at some point. The last thing that we could do was we could put our hand over, we could grab something, put it at the tip of our gun and shoot that object. And this code is actually really simple. It may even be simpler to do in C++ than in Blueprint, because in Blueprint it's the if statements that start becoming messy. But in C++ they're pretty simple. So with this feature, all that we really need to do is handle, we just need to change two functions. When we let go, we want to check if, the left cone, which is being used to represent the tip of the gun, is interacting with the thing that I'm holding, and if so, then we pop off anything that is already on the gun. Like, say that we keep attaching something to the tip of the gun. Anything that's on the gun we pop off, and then we attach the new one, which we attach the new one to the tip of the cone, or to the tip of the gun, and that's all we have to do and let go. And then for shooting, we just have to handle the case where something is in fact on the gun. So we checked if there is something on the gun, then we detach it and then we launch it. Kind of the same as with the bullets. So, it's simple enough. And, it's easy. This is easy to do. So, in let go, if there is a thing that I grabbed, so if I am in fact holding something, we just need to handle that case where the left cone is overlapping the thing that I grabbed. And we already did something like this with the grip, so we already know how to do this. So that's this, if the left cone is overlapping with the thing I grabbed. If it's not, then we will drop things the old-fashioned way. There was Visual Studio being helpful for once. So, let's see. The first thing that we should do is we need to keep track of if there is something on the gun, so that, let me minimize these. We need to keep track of if there's something on the gun, because when we do decide to shoot it, we need to know whether or not to shoot a bullet or to shoot the thing that I grabbed, or the thing that's on the gun. And so I have something that's basically the same as thing I grabbed, except it's thing on gun. And it's still a collectible, it's just that I use this to detect if there's something on the gun instead. So that part is simple enough. So the code will be similar to the blueprint code. If there is a thing on the gun, meaning that it's attached already, then we're going to pop that one off, and in this case when we're not shooting it, we're just going to pop it off. So, that's simple enough. And then one way or another, the new thing will get attached. So the thing that I'm currently grabbing, which I'm now trying to put on the gun, will no longer have physics. It actually shouldn't have physics anyway if I'm grabbing it. So this is probably not necessary, but whatever. Force of habit because of dealing with broken physics engines. We're going to disable physics, which may or may not be necessary. It probably isn't. I can't think of a good reason why it wouldn't be, or why you would actually need to do this. Then we just attach the thing that I grabbed to the left cone instead of my right hand. And we'll snap it to the cone, or sorry, yeah, we'll snap it to the left cone, which is the tip of the gun. I mean, I suppose you don't need to do that, but I think it's fine. You could have it be askew. Then, thing on the gun is now whatever the thing I was grabbing was. And the thing that I was grabbing is now nothing, because I'm not grabbing it anymore. So, this should be all that we need to handle the attachment and popping off of the collectible on the gun. And then after this, we'll just need to test shooting it. For now, I just want to test. I'm just going to show you quickly that this works, hopefully. The only reason that I can imagine that it wouldn't work is if something's collision settings are not set correctly. I need to use both my hands, magnetic grip for the lazy of us. And so now I should be able to do this. Let go, pop. And I still shoot bullets because I haven't handled what to do when the cube is on the gun when I'm shooting. So right now it's just shooting bullets. The bullets are shooting out in weird orientations because they're colliding with the cube when this is happening. But more importantly, for magnetic grip, you probably, I don't think I did this in the lectures, but for a magnetic grip, you probably want to, or for any of the grips, do you actually? I think it makes sense to pull this off of the gun actually. But, I don't know, I guess you would need, I didn't actually handle this case during the lectures because I didn't think of it. But if you do want to be able to grab this thing off of the gun, in all of those grab functions, you would need to handle whether or not the thing that you grabbed is equal to the thing. Or you want to check if try-cast, which is the thing that you're trying to grab, is the same as thing on gun. If so, set thing on gun to be null, and then grab it instead. But I didn't handle this case in the lectures, so I'll leave that for you to do. I just want to show that if I do this, it should pop off the colorful cube. Pop. See? So, that works. There's just that edge case that I just mentioned, where you try to grab the thing off of the gun, because I don't think I thought about that during the lectures. I mean, I don't think it's in any of my blueprint code. Yeah, it doesn't look like I was checking. We don't have to worry about it though. Maybe we have time. I think this should be very short, so I'll do that quickly afterwards. Anyway, let's just handle the shooting. So, for shooting, I'm just looking at my reference code to make sure I don't mess it up. So, if thing on gun, then we want to shoot that instead. Otherwise, we do it the old-fashioned way. The only thing I don't like about that is this. I actually prefer the else statement to be here. To each their own. So if there's a thing on the gun, then we detach it first of all, so that when we move the gun while the thing is flying, it doesn't mess up the physics. Then we want to re-enable that thing's physics. And then we just we do something similar to what we were doing with the bullet. We add impulse. The thing is, the bullet I made 100 kilograms, but the cubes are only 5. So this might be a bit too much juice. I'll leave it at that and see what happens. And then finally we need to set thing on gun to be null. And that's it. Shoot gun should actually, this part should happen regardless. But this should theoretically be all we need to shoot this thing. And this is just using the same old process that we've been using thus far. for all these other things. So, you know, one of the things about learning Unreal C++ is that, yeah, there is a steep learning curve, but at a certain point, a lot of the code does just start looking the same. Like, you already know how to do it, so it becomes less and less challenging over time. Until, of course, you run into a really hard problem, then it's a hard problem, but you do know C++, so harder problems are more manageable than when you didn't know how to do them. Anyway, magnetic grip, let go of it, and then shoot that bad boy. That was not enough juice. Let me add way more juice. I think this might be too much now, but whatever, it's a cube. Who cares? You know, it's not the most realistic simulation that exists. Let's see if this was the juice. Snap, let go, pew. There we go. That works nicely. Pew. And I can still grab things, and I keep grabbing the thing off my gun. This would cause, so the problem that with, if I don't check if thing on gun is null when I'm doing these grab functions, what can happen is that if I grab it like this, right, I'm never setting, so this thing on gun is still this object, even though it's no longer there. So let me let go of it. And what'll happen now is that when I shoot the gun, it'll shoot that thing. See? Because I haven't nullified the thing on gun. So that's the problem that we need to worry about. Let me just show you quickly that it still pops off the cube. It popped off the old cube, although you can't tell it's the old cube. Actually, we can handle that now. Cube. The physics is broken right now. I don't know if the bullets are just moving too fast, or maybe it's a quality setting that I didn't set to be correct, but some of the physics, it's like the collisions are not working right. I'm guessing that, based on the fact that I don't see the shadows of the bullets that are back there, I only see them when they come closer, I'm guessing that the quality settings are just lower. Like maybe I accidentally used mobile settings. But in any case, let me just show you that this works. So when I try to attach the new cube, it will pop off the old one. See? And just for the sake of completion, let's handle these extra cases where I grab something off of the gun, or I grab something that's on the gun. So this is simple enough, actually. The grip pressed. Actually, this is very easy. If thing on gun is equal to try cast, thing on gun equals null pointer, and I just throw this if statement into all of these different types of grabbing. Easy enough. Equals closest object. I think that's all I have to do to handle this edge case. Well, it's not really an edge case. I think there are a lot of reasons why you want to pull it off of the gun. And then after this, I mean, this is the last feature, so after this I'll just finish off with some closing comments. So grab this, and I can shoot this, grab this, and if I grab this again and let it go, it should not shoot that, it shoots bullets. Yay, edge case solved. And now everything works as it should. And we have our fun little collection game. Well, it's not a collection game yet. I haven't actually implemented the assignment 5 code, which I didn't in lectures, so I'm not going to here either. But you know, everything works as it should, and you now have the code and hopefully understand the code that lets you have a bunch of different types of interaction techniques in VR. So this is all done, and as some closing comments, I want to show, maybe I should show you quickly how Blueprint can interact with C++. So throughout this whole time, even though I've been doing all the code in C++, but the positioning of my gun and stuff, I was actually using this Blueprint pawn class, which was wrapping the C++ class. Like, it wasn't doing anything except you could use it to position things like the ray gun and the cone and stuff like that. Let's say that you wanted to call one of these functions from Blueprint. So let go. Let's say that I add an extra input that's let go blueprints, like let go BP, which will forcibly let go of whatever I'm holding, and this will be something that is handled specifically through Blueprint. So I'm going to make the menu button on the controller, and should be fine. Make sure that this is player 1. So I'm going to use this function. I'm going to use this input in only Blueprint. So in only Blueprint, let go BP. I'm going to print off something. Let's see, hello. Fine, I'll say let go BP. And what this will do is it'll call the C++ function let go. And that will just forcibly let go of whatever I'm holding. See? And this is in fact the C++ function. If you double click it, it will open up the C++ definition of this function. And this should work. So if I grab this thing and then I'm going to hit the menu button and I let go of that thing. See? And that code was just being handled in Blueprint. And it works with all this stuff. And that's simple enough. And because I did U-function Blueprint callable, Blueprint can call my C++ functions. And that's really nice because say that you do have C++ functions. So all of this code that we've been working on is simple enough that it probably doesn't make sense to do it in C++ just because of the difficulty and time-consuming process. But say that you do have a function that C++ actually is useful for, like working with one of the NVIDIA libraries, or working with a mesh that has millions of vertices, like the Unreal 5 demo. I can't imagine that they were able to load billions of vertices in a level using Blueprint. That must have been done in C++, or some maybe even lower level than that. If the fact that this U-function Blueprint callable, which lets you call C++ functions from Blueprint, is nice if you do actually need C++ for these things and you want to do the rest of your code inside of Blueprint. That's what it's for. And in industry, in Unreal 4 industry work, you do normally interact with them that way. You write the really complex or slow code in C++, and you do the simpler code that takes advantage of things like Blueprint declaring these input actions for you instead of needing to bind them yourself. All of this you handle in Blueprint and call the C++ functions when you need to, and that's simple enough. Like I use C++ to output things to file, but you actually don't need to do that anymore. I don't do that anymore because I use UDP, but you know, you can probably imagine use cases where you would want to call C++ functions from Blueprint simply because Blueprint's not fast enough to do it. What else? I mentioned that you could add, I already mentioned at some point you can add C++ to a project that's already just Blueprint. And once you do that, it will add, let me find this folder. Once you do that, it will, so, oh wait, that's not the right one. Once you do that, like once you add a C++ class to something that's only Blueprint, like for example, why does it keep doing that? For example, this project it doesn't have a source or a Visual Studio solution. Once you add a C++ file to this, it will add those for you. And then from there, it just kind of works like the project that we've been working on. So that's simple enough, I think. What else? For practice, I mean, to get better, I would recommend first just trying to implement this code that we've been working on. I will post a GitHub project that has this code for reference, but I would recommend trying to type it out yourself just to kind of get practice with the syntax. Another good way to practice, I think, is compare code from the Unreal templates that have both Blueprint and C++ equivalents. So the first person character is a good example. This character was the first person character that came with this project because I extended the first person template. And you can see here they have all of the, they have the gun and all of this stuff. They have their animations, like when you shoot the gun, and they have the, touch inputs and all of the other basic stuff. And then they have the C++ code that shows you how they're setting it up, like they're loading. I don't even know if they're loading the meshes here. I think they're just handling attachment and initializing them and positioning them. But then they have all this other code, like you can see their bind code and other things. So comparing these projects is a good idea. I would recommend just comparing it directly to their Blueprint, because I think that Epic Games did a pretty good job of trying to keep the Blueprint and C++ as close to each other as possible. I'm just opening this up quickly to show. And apart from that, I think that you will just learn. I think that you'll learn C++ most effectively by doing these kinds of practice exercises than by trying to learn it from a book. At least with engines as complicated as Unreal, it almost is not useful to try to learn it from a book because the engine implementation will differ so much. But anyway, you can see their Blueprint code and add movement input, and I actually disabled this, but like when you, or this I think, so here they were playing this animation where it shoots the gun, and I think it had like a particle effect or something. Yeah, and this exists in C++ too. So yeah, I would recommend just comparing these, and this code is simple enough, so it shouldn't be too much of a problem. And if you want more complicated practice problems, the Epic Games on their site, they have tutorials for C++ for much more complicated things that you can also play around with. And people have all of their own projects on GitHub, which are also worth playing around with as well. So that's basically everything on my list. One last thing. If you recall, for Oculus, for the Vive, the tracking origin is already right. Like it already correctly sets your camera to be whatever the height of it already sets your head to be relative to the ground. What we did in the Oculus, that wasn't the case. Like with the Oculus, you spawned inside of the floor, I think. Let's see. The way that you handled that in Blueprint was you did set tracking origin to be the floor. By default, I think it was eye level, unless they changed that at some point. And in C++, you can still do this, and you can do it in begin play, just like we did there with this function. To do this, you need to include the head-mounted display library. Normally, you would need to include the module that comes with this, but inside of the build.cs, if you recall, they already include head-mounted display, so we don't have to worry about it. So I included this, and now this function here will handle, it just does the same as this blueprint. That's basically all that was on my list. So yeah, good luck with learning more C++ and possibly getting into game dev, the actual industry, not indie dev. So, bye.